Howdy everyone, and welcome to our video on the Hinge Theorem. So real quick, we're going to talk about the Hinge Theorem. This is a pretty short video because it's a pretty light concept. The idea of the Hinge Theorem is this very wordy definition, but we're going to break it down together, okay? As it says here, if two sides of a triangle are congruent to the corresponding sides of another triangle, and the included triangle of the first triangle is smaller than the included angle of the second triangle, then the third side of that first triangle will be smaller than the third side of the second triangle. Whew. Okay, so let's break that down a bit, right? What is going on there? Lots of big words, lots of weird ideas. Let's break it down. So if two sides of a triangle are congruent to the corresponding sides of another triangle, what that means is these two sides right here are congruent and corresponding to these two sides over here. So if you were to do this again using your hands, because a lot of stuff we do in this topic can use your hands are probably not changing in length. So if I do this, I make one triangle. If I do this, I make a second triangle. So they're saying compare the two triangles you can make by doing this. This is why it's called the hinge theorem. You're building a hinge, right? Likewise, I could think of it as a door, right? This is the door frame. This is the door. I'm opening and closing a door. I can think of it as jaw, right? I'm opening and closing my jaws. Nom, 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 you know? So it's anything that has two sides staying the same, but they can be different angles apart from each other. A hinge, right? Your elbow, that's a hinge. So if I keep the side lengths the same, right? Then if the included angle of the first triangle is smaller than the included angle of the second triangle, so let's break that part down. Whoopsies. All right, let's break that part down. When they say the included angle, we didn't talk about this super much in class, but that means this angle right here between the two sides, right? Like in a side angle side relationship. If I know that the first triangle has a smaller angle than the second triangle, is what it's saying. So I'm going to make two triangles, and I'm going to look at the one that's narrower, right? A narrower one, or the one that has the door open less, or where I haven't raised my arm as much, or where my jaw is a little less open. What that means is, what it implies is that the third side of the first triangle will be smaller than the third side of the second triangle. So to put this really simply, if I open a hinge wider, the clearance between the hinge ends is larger, right? Open your jaws bigger, you can fit more food, right? This is for candy, this is for Shaggy style stacked sandwich, right? Open the door wider, someone can squeeze in a little easier. I open my elbow wider, I can fit a bigger like fruit here and crush it with my biceps, right? That's the idea. When I do this, the distance between my fingertips is bigger than when I do this. That's the hinge theorem. It might seem kind of trivial, but the idea here is a very powerful relationship being shown between the angles of a triangle and the sides of a triangle. When I control these two sides and keep them the same, changing an angle changes the side length. So once again, we're seeing a very unique relationship between sides and angles in a triangle, one that is not necessarily shared by other shapes. And we use that a lot in future parts of geometry. So recognizing this relationship is a very important part of triangles. And that's kind of it. So what we had for our homework, and I'll give you a little hint here if you're watching this video, right? We did all these notes and you were able to take the notes on the Agile Mind, right? And we were able to play along with it. But the last thing we did on our notes here, we had this problem. So I want you to try these out together, maybe with the video here, right? We had this problem, then one more. So using the hinge theorem, the key thing here is before we've been giving you exact information, like these are congruent, right? But now we have the ability to say things that are estimates. This is larger, this is smaller, right? And that's useful in its own way. So for example, here, I have that this is 43 degrees over here between two side lengths that are corresponding and congruent to these two side lengths. But I don't know what angle M is, right? M is the one that corresponds to I, so I need to figure out what that angle is. Well, I'm going to use the triangle sum theorem to be able to figure it out by getting rid of 63 and 74, right? Because they would add up to 180. When I do that, I'm going to get 43. Hey, look at that. It's the exact same angle, right? If this is the exact same angle as that one over there, it's not open larger, it's not open smaller. That means that we have a side angle side relationship. So these are equal side lengths. HJ is equal to KL. And we know that because of CPCTC, right? Now, what if I was given something like segment EG is the median of DGE, right? Remember, median meaning that it goes to the midpoint. So what I have here is that this is congruent to this. This is a side that's shared by the two triangles. So if you remember from when we did congruent postulate problems, that means it's also congruent to itself. So I have two sides that are corresponding congruent. Then one is 88 degrees and one is 92 degrees, right? So how would we figure that out? Well, 88 is smaller than 92, so DE is smaller than EF. It's that simple, right? The last problem we had here was testing whether you can apply this yourself. So I'll give you a hint for having watched this video, right? I want you to try this out on your own and finish it. But Gary is trying to use the hinge theorem here. But remember, the hinge theorem requires not just that angles are larger and smaller, but something to do with the very idea of a hinge, right? Something with the sides of the hinge is important. Not every angle that's bigger or angle that's smaller is guaranteed to have a bigger and smaller opposite ending. So try to figure out what might Gary be missing that might not allow them to apply the hinge theorem here. Why is it so important that we think of hinges as jaws or elbows or hands moving apart or doors and door frames, right? There's some other piece besides the angle itself. Okay, that's the homework for that day. So I hope that helped out with finishing up those notes, and I hope you were able to get some of those problems in. And I hope that helps out as a Kickstarter for this one. Like I said, pretty short. So I hope you have a wonderful day.